Hi everyone. So today my talk's going to be about taming LLMs with structured outputs. And looking at that title in a first glance, you might be left confused. What does it mean to tame an LLM, or what even are structured outputs? But hopefully by the end of this talk you'll know what the entirety of that title means. So starting with LLMs, or large language models, you've probably heard of them in the past 2 years or so. Things like OpenAI's ChatGPT, Anthropic's Claude, or Google's Gemini. These are all models that take in text as input and they generate text as output. And they've shown their ability, I think, to all of us, and they've taken us all by surprise. And I would say two key factors. The first being reasoning. So on the right is an example where I asked an LLM, to ChatGPT in this case, to solve a single variable equation. And over the course of several steps, it showed accurate reasoning. And by the end of it, it correctly evaluated what x was in the context of that equation. And the second factor I'd say that where LLMs really shine is with creativity. So in this case, I asked an LLM to create a new Pokemon and generate information for a trading card for that Pokemon, including the basics: name, HP, type, and 2 attacks. And it was able to do that, and it creates a coherent, coherent sort of like blob of text. There's a name that makes sense, 2 abilities that follow with whatever type the Pokemon is and its name, and everything just sort of seems to just work all together. So that's an example of how LLMs are really creative in their outputs. But I think there's a big problem with LLMs, and that's that they're hardly consistent. What I mean by that is, I think, is best shown in an example. So in this example, I asked an LLM to write me a multiple choice geography question with 4 different answer choices. So it did exactly that. It said which country has the longest coastline, and it gave 4 choices, and it said the correct answer is B, Canada. And then I asked it to do the same thing again. You can see slightly different question here, but what I want to point out when we put these 2 generations side by side is that there's a glaring difference, not only in, of course, the content, but also the formatting, right? You can see on the left-hand side, ChatGPT chooses to use like parentheses to sort of like in each of the answer choices, and the correct answer is formatted completely differently compared to how it was formatted on the right-hand side. And the reason for that is that LLMs are non-deterministic. This means that you can give an LLM the same input, but it doesn't guarantee that the same output is going to be generated. And you might be thinking, why does that matter? As a human, I can comprehend both of these generations, and I see the formatting doesn't really matter much to me. But it's when you use your LLMs in code where things get a bit more dicey. And I would say that using LLMs in your code outright without any safeguards is actually very dangerous. And we'll follow through with this geography example, let's say, and see why that is. So let's say I have, instead of using like a manual workflow to generate those geographic trivia questions, I have like a programmatic workflow. So instead, I have a method called generate trivia question that returns a response from an LLM like ChatGPT, and then I have another method called parse trivia question. And that method is just responsible for taking that output and making it into something that I can use to then display that question in my own UI. The problem with this is that if we get an unexpected response, so let's say an unexpected response where I was attempting to parse the questions that looked like what the left-hand side generated, but I get something that resembles the right-hand side, my code completely breaks, and I get a parsing error because the response that the LLM returned to me was completely unexpected. And the good news about this is that you can actually work around this, and there's a couple different ways to do so. And the first one that may intuitively come to your mind is, hey, we can maybe just ask the LLM to give us the output in like JSON, right? Give me the output in this specific format, and that's called prompt engineering. So when you modify a prompt to optimize the output, that whole process is called engineering the prompt. And so in this case, I did exactly that. So I added a small message right after my initial request, and I said that the output should follow the JSON schema below, where the question there's choices in an array, and then an answer, and then provide me the index of the correct answer as it corresponds to the choices array. And it works, but the problem is it doesn't always work. It's not foolproof, because simply modifying the prompt and asking something just in plain English, asking an LLM to do something won't always work. For example, I ran the same thing again a few times, and then I got this. I did get the JSON eventually, but there's a chance that the LLM prepends the desired output with like a bunch of unnecessary information, or it says like it just the return JSON is not the only thing in the output. And so that's why strongly worded prompts, no matter how strongly worded they are, can't guarantee you that the LLM's output is going to match the schema. So this solution works. It's a better solution, but it won't always work. And when we're writing code, we want to be 100% sure that the output we get is something that we can parse, and that are the things downstream of the LLM can use. And so you might be asking, what do we do? Intuitively, the only thing that you could think of is probably just changing the prompt. But there's actually a bunch of improvements you can make and to get a guaranteed response that aligns with the schema. And that's where structured outputs come in. So it turns out we can directly enforce a predefined schema during the generation process, and so that the LLM follows that schema when producing outputs. So it's important to note that this isn't the same as simply asking the model to return JSON, as I did earlier, and that constraints are added to the model during the generation process so that the response only contains valid JSON. And if you're interested in how the process works under the hood, it's kind of outside of the scope of this talk, but essentially the JSON schema is sort of converted into like a context-free grammar, and a grammar is basically a set of rules that define a language. And so that grammar is used to aid the LLM in the generation process, and it's used to limit the scope of what it can generate so that it aligns with the schema. So you might be thinking, when we generate a key value pair on one line in sort of a JSON object, the logical next character that we have to have is a comma to separate lines. So the grammar limits sort of the scope of what the LLM can generate, so it ensures that the comma is the only thing that the LLM can return in that scenario. So to show you to show you a new diagram and explain how it differs from the previous one, if we have a schema, we're guaranteed that the output generated by the LLM follows that schema. And so anything downstream of that, let's say displaying our LLM's response in the UI, is going to be you can guarantee like with certainty that it's going to work, and the UI is never going to break because of an invalid LLM response. And so there's good news. Structured outputs are natively implemented in ChatGPT, and the ChatGPT API actually supports them. And so if you're looking to use structured outputs, to do so is very simple. I have an example for JavaScript here, but the process in Python is very similar. I'm using npm, using Node.js in this case. So I'm using npm to install the OpenAI library. And then I'm also going to use npm to install Zod. So Zod is a library that's typically used for like form validation. So it allows you to define schemas very easily. But in our case, we're going to use those schemas to validate the output of the LLM. If you're using Python, Pydantic is a similar alternative to Zod. And here's the sort of the main part of our code that we're interested in. From line 6 to 15. Sorry, 8. I'm using relative numbering, so ignore that. But the highlighted portion, I create a Zod object called trivia question, and I basically say there's only 5 things I want in here. I want a question, a correct answer, a wrong answer, 1, wrong answer 2, wrong answer 3, and each of those things has to be a string. I don't want anything else, and I want the type of those things to be ensured, and the type of those things should be a string every single time. And so this aligns with our goal of generating trivia questions with structured outputs. So this is the schema I'm going to use in this case. And then on the next slide, I'm basically making a call to the ChatGPT API. I'm specifying the model and our prompt. But the main thing you want to note is that the response format includes that Zod object that we defined earlier. You can see trivia question right here. And so ChatGPT is going to use that schema to generate output, and it's going to do that, it's going to add a bit of determinism to our outputs, and it's going to make sure that our outputs follow this schema every single time. And the only thing left to do is to run the code. And if we run that little script that we've written, you'll notice that in a few seconds' time, we get back a JSON object, and it has all the fields that we want, and they're all of type string. So that's and it generates a question that's pretty cool too. So we've successfully generated something that moves away from just generating plain text in unpredictable formats. We've made it into a JSON object that we defined before even generating. So I think that's a pretty good development. And I think that structured outputs have a lot more use cases than just structured generation. An obvious sort of like use of structured outputs is to actually extract information, not generate. So let's say that I run a site and I have a form on that website, and I want to replace that support form with a chatbot. And so the main issue that you'll find when doing this is that when your chatbot asks a question like, can you please give us your name, email, and phone number to your customer, and the customer gives a natural language response back, you have to find a way to parse each of these things and put them into your database. And so without structured outputs, that's pretty hard because, as we said, we can't guarantee that LLMs are going to return a response in a specific format. But with structured outputs and a prompt to accompany them, like something like parse the full name, email, phone number from the following text messages, we can get the output to be in the format we want every single time. And so you can kind of replace something like a form with like a more natural chat, and that creates for a better user experience in some cases. So that's one use case for structured outputs in structured extraction. There's also a more advanced use case of function calling. So this one is a bit more complex, but let's assume that we have an app. It's a weather app, but it's not like a typical weather app where you just go and check the weather in any city. Instead, it's an app where you basically ask a question in natural language, and then the app gives you back a response that's complete and accurate. So let's say a user comes to our app and asks us, should I wear a coat in DC today? And so the first thing you might be thinking is, okay, we just take that query and we send it to ChatGPT and we ask for an answer. But the problem is ChatGPT doesn't have access to current data. It's a model that was trained probably months ago, and it has no way of accessing what the weather is in any given place. But what if we give ChatGPT the user's query, but we also give it a list of functions that we've written? So let's assume that I've written a function called getWeather, and it takes in a parameter, let's say, of type string, and it's the parameter is called city. ChatGPT can then take that information, the query and the list of functions, and it can say, hey, I don't have access to weather data, so I want you to first give me the result of this function call. So it'll give us the function name and then whatever arguments, and then it'll send that back to us. We execute that code, we take the response from that function and send it back. And so we're giving, in a very cool scenario, we're giving ChatGPT access to data that it doesn't have, and it's asking us for that information ourselves. Once we give it back the data from the weather data that we got from executing the getWeather function, let's say in DC that day the weather's 82 degrees Fahrenheit, 0% chance of rain, ChatGPT is able to make a complete and accurate response, and it can send us back something like, it's hot, no need to wear a coat today, and we can return that to the user. So that's an example of how you can combine your own functions that you've written that maybe pull more current accurate data with an LLM that has the ability to process natural language and sort of make those complex reasoning decisions. And so I think, I hope that throughout this talk, you've kind of seen a bunch of real-world applications that LLMs can have, and how structured outputs enable those applications, and add a bit of, sort of guardrails to LLMs when we use them in software. But I basically want to talk about why I got into structured outputs to begin with, and that's because I'm a second-year student at the University of Maryland, but in my free time I'm building a platform called Azigi, And what a Ziggy is it's basically a web app that allows teachers to transform their educational materials into live interactive game shows. And so as a student, I really felt that I liked when my teachers used to sort of play these interactive games. But the issue was that it takes a lot of time, and it's a lot of work for them. And frankly, their time is better spent creating the exams or creating actual material for us to review with, rather than creating these games, which are very time consuming. So I sort of built a platform where you can upload your documents, your audio recordings from your lectures maybe as a teacher, and structured outputs are actually used in the process when we take those documents and convert them into a Jeopardy game, let's say, a full-on 6x5 grid of 30 questions that people can play with. And so yeah, that's kind of how I got into structured outputs. And my main goal with this talk was basically to outline how how AI can be used in software safely. But I think that structured outputs are just one way in which AI is sort of enables developers to use AI in software. But I feel that it's my hope that we can continue to incorporate a lot of these new models that are coming out that are things that we've never seen before. They're unlike anything we've ever seen before. They're very powerful, and they have a wide variety of applications. And it's my hope that combining them with software can lead to a better future for a lot of people. Thank you.